All right, folks, I want to go through a little proof on some of our logarithm rules. As we move into the remainder of this chapter, we're going to use some of our logarithm rules to condense and expand some expressions, and it's important that we understand where these come from. So on this video, I'm going to go through the proof for the logarithm property that says that if we are taking the log of the product of two values, that we can separate that into two separate logs where I'm going to add those together. So I want to take a moment to understand this. The proof of this is very similar to the proof if we were working with division of two arguments and that they would split to addition. So if you understand this one, you would certainly understand the other. So let's look at this proof. In order to begin this, what we want to do is we want to initially define a few things. What are we starting with? We're going to start with the fact that we're going to have a to some power, I'm going to say capital A, is going to equal m. And I'm also going to define that I have a to the power of b, capital B, is going to equal n. Now, it also is good for us to think of these in terms of logarithms. So I could certainly rewrite these and I could say log base A of m equals a. And I could say log base A of n equals b. Those are good things to remember, okay? I'm simply using my log and exponential properties to move back and forth. So let's start with the fact that we are going to say, we're going to start with the fact that we have log base A of m times n. And the goal is to transform this, just like I have here, into these two separate pieces. So what we're going to do first is we're going to do a little substitution with our initial definitions, and we'll write this as log base A. And instead of m and n, I'm going to write a to the capital A times a to the capital B, okay? Then, understanding my exponent rules, if these have the same base, these exponents could be added together. So I can rewrite this as log base A of a to the a plus b, just basic exponent rules there. Now, I know from earlier in this chapter that I know that log base b of b equals 1. So if I have log base A of a to the a plus b, this is going to have to simplify into an a plus b. Now, up above, what we saw is that when we took our initial values and we wrote them in their logarithmic forms, we were able to isolate the a and the b, so we can substitute one more time. So our a is going to be actually log base A of m, and our b is going to become log base A of n. And now we have shown that log base A of m times n can transform into the sum of those arguments written as their own logs. So that is that property. So you might need to watch this again to kind of follow what's going on there. We're certainly not going to require you to prove this, but it is helpful to understand how that is actually working.